Hello and welcome. Lesson number 7 on identities. Yeah, we'll still be taking out common factors, but we'll be factorizing trinomials or three terms to solve the identity. Problem number 1 can be sin 2x minus cos x divided by sin x minus cos 2x equal cos x sin x plus 1. So taking my left hand side, I'm going to try to prove that this equals to that. The left hand side, sin 2x is a double angle. If I expand it, can only become 2 sin x cos x minus cos x. On the right hand side, or not right hand side, the denominator, I have sin x minus, and I have cos 2x. Because I have sin x, I'm going to write cos 2x in terms of sin x. Right, and there you can see on the right hand side, I also have sin x at the bottom. So cos 2x then becomes 1 minus 2 sine squared x. On the top, on either side of the minus sign, you see there, common factor, cos x. Do you see it? Right, so if I take that cos x out, I have 2 sine x left, minus anything divided by itself, gives me 1. The bottom, if I simplify, negative times negative, gives me 2 sine squared x, right, plus sine x, and negative 1. So now I have a trinomial, 3 terms, in standard form, squared to the power 1, constant term, right? On the top I've already factorized, cos x 2 sin x minus 1. Right, if I factorize the bottom, 2 can only have the factors 2 sin x times 1 sin x. Right, and 1 only has the factors 1 and 1. Because it's negative, 1 is negative and the other one is positive. If we check there, minus sin x for the 2 closest. The 2 furthest one becomes 2 sin x. 2 sin x minus sin x would give me positive sin x. Right, and automatically I assume you can see that bracket and this bracket is the same. So therefore we can cancel the 2. I'm left with cos x on top, sin x plus 1. So that is the same as my right hand side. So the statement is valid and true. Right, and I've proven the identity. Problem. So number 2, we have again sin 2x plus sin x divided by cos 2x minus cos x equals sin x over cos x minus 1. So I take my left hand side, right, write down what's given. Sin 2x can only expand to become 2 sin x cos x plus sin x. Bottom cos 2x become 2 cos squared x minus 1 minus cos x. Chose cos because I have cos x. Remember the previous one, because I had sin x, I wrote that in terms of sin. Now because I have cos x, I write it in terms of cos x. Right, on either side of the plus sign, I assume there in blue you can see common factor sin x. So if I take out sin x, what am I left with? Or before I take that out, there is just rearrange. 2 cos squared x minus cos x minus 1. So on the top, take out sin x as a common factor, and I'm left with, if I remove that, what's left? 2 cos x. No? Anything divided by itself, sin x divided by sin x, plus 1. The bottom 2 cos squared x can only become cos x times 2 cos x, minus 1 can only be negative 1 times plus 1. I want minus cos x in the middle, so let's see. The closest, minus 2 cos x. 2 furthest ones, cos x, so minus 2 cos x plus cos x would give me minus cos x. So I factorize correctly, and again, 2 cos x plus 1 divided by 2 cos x plus 1 would cancel. I'm left with sin x over cos x minus 1. If I look at this answer, it's the same as my answer on the right hand side. Therefore my left hand side equal my right hand side. Right, so I hope you follow, I hope you're enjoying the lesson. I hope you're learning. So feel free to pause it, redo it, write it out, try to do it on your own, see where you make errors, write a note where you made the error. Your brain will always remember errors. Right, once you know why you make the mistake, when you see the problem exam, you're like, oh, that was the problem where I made that error, and therefore you end up getting it right. Right? Let's look at the next problem. Right, so in problem number 3, I have sine 8x minus sine 4x divided by cos 8x plus cos 4x equals sine 4x divided by cos 4x plus 1. Right, there I'm going to make that double angles, right? Because I have 4x, see when I write 2 times 4x, 2 times 4x, I'm bringing 4x and 4x there so I can take out the common factor. Right, so if I expand, that will become 2 sine 4x cos 4x minus sine 4x. Here at the bottom, cos 2 4x. Right, because I have cos 4x, I'm going to write this in terms of cos. So that gives me 2 cos squared 4x minus 1 plus cos 4x. On top, either side of the minus sign, there's sine 4x, take it out as a common factor. So if I remove this, what's left? 2 cos 4x minus 1. Remember, anything divided by itself always equal 1. Alright, 2 cos squared x, 2 cos squared 4x plus cos 4x minus 1. I'm writing it in standard form so I can factorize as a trinomial. So at the bottom, 2 cos squared 4x can only be 2 cos 4x times cos 4x. Again, negative 1 there can only be negative 1 plus 1. If I multiply out the 2 furthest, 2 cos 4x minus cos 4x, which then gives me cos 4x. Again, with most fraction problems, there will always be something cancelling on top, something at the bottom in brackets. Remember, this means multiplication. Sine 4x times that, this times that. Because in multiplication, there's no plus minus signs. I can cancel top and bottom. But if there was a plus minus sign there in between, Bodmer states I first have to solve the top before I can solve the bottom. So those two cancel, and I'm left with sine 4x over cos 4x plus 1. And that is what I was looking for on the right hand side. So now my left hand side equal my right hand side, and the statement is true. If you enjoyed the lesson, please share, subscribe. I'm here to help as many learners as possible, and it's costing you nothing except data. Wish you nothing but the best. Bye.